Just like UI controls, reports render most efficiently if they use optimized data queries. If you allow users to customize aspects of a report using parameters, your queries can take advantage of the user-supplied values to retrieve only the set of data required for a report run. This approach is supported by different data source components, and the following demo illustrates it for a JSON web service and a SQL Server database. In this demo, I begin with a simple report that uses a JSON web service to retrieve its data. You can see the JSON data source component, which is configured to use a connection string called all-data-connection. Here's the connection string in app.config, a URI pointing to a demo web service. I go back to the report and activate the preview, and you can see the report rendered with a full dataset. Country names run from A to Z. You can also see in the preview that the report has several parameters. These aren't used at the moment, but I'll show you how to enable them to limit the amount of data retrieved from the server and modify its sort order. I activate the designer again and choose the take parameter from the field list. Its configuration allows for null values, making the parameter optional. The type is number, since the parameter defines the maximum number of rows that will be delivered by the server. Now I select the data source object at the top of the hierarchy in the field list. I use the ellipsis button for the JSON source property to bring up the data source editor. I change the radio button selection to modify the connection parameters and proceed to the next page. The web service URI is visible in the dialog, and I can now add path and query parameters. I add a couple of path parameters as a demonstration, and you can see in the URI preview at the bottom of the page what the result is. For this sample, I don't need path parameters, so I remove them again. Instead, I add a query parameter, which adds an element to the result URI following the usual question mark separator. I change the name of the new parameter to take. Note that this does not have to be the same as the report parameter name, but of course it is intuitive to use the same names for both. I check the box in the column expression, and then I select the report parameter take from the combo box in the value column. I'll show you examples later for other types of expressions, but for this first demo case, I'm already done. I click Next. I don't need any of the settings on the next page, but of course you can add values here if you need basic HTTP authentication parameters or custom headers to be sent with your request. Note that header parameters can also use report parameters or expressions as their source. On the next page of the dialog, I change the name of the modified connection string to take parameter connection. I also change the radio button selection to save the parameters I specified. This is easy to forget. If you have defined parameters for use at runtime, make sure to select Yes here. The final page of the wizard provides the usual overview of the fields found in the data source. I leave the selection as it is and click Finish. I bring up the preview again, and initially the full list of countries appears. But now I can change the value of the take parameter, called max row count in the parameter panel, and limit the data. I try a value of 10, and the list is restricted to 10 rows. Of course, you could also provide fixed parameters to your data service or other data source. This example is already advanced since it optimizes on the basis of an end user choice. As a second example of this technique, I'll add support for the sort parameter of the demo data service. This parameter requires a specific syntax, and I'll show you a static example first. I bring up the JSON data source editor again and add a new query parameter. This time the name is sort. And I enter a string for the value. This string represents a JSON object with nested fields to specify the field name to use for sorting and a flag to sort in descending order. Like before, I proceed through the wizard pages and save the connection string. For future reference, using the name sort connection. I switch to the preview and the effect is immediate. The rows are sorted by the population field. For a more realistic scenario, I'll now make the sort parameter dynamic. A parameter called sort field is already configured for the report. And you can see the lookup values I configured, which reflect the field names of the data source. These will be available to the user in a combo box. The sort descending parameter is a Boolean type, appearing in the parameter panel as a checkbox. I bring up the JSON data source editor again to modify the query parameter definition. I check the expression box for the sort parameter and bring up the expression editor. Then I modify the expression to construct the JSON object dynamically on the basis of the report parameter values. I save the connection string as dynamic sort connection this time. The preview comes up with the default order, but now I can select a sort field to change it. The descending order also works as intended. Now you've seen some scenarios involving the JSON data source. I need to point out that other data sources offer similar parameter functionality adapted to their data access layers. As an example, I open the second report in the project. This report is configured to access a Microsoft SQL Server local DB instance on my machine. You can see the connection string in app.config by the name SQL Data Connection. The report displays master detail sample data. For the SQL data source, individual queries are configured in the data access wizard, one for each query source on the server. In the demo case, there are two queries, one for the master level and one for the details. I also set up a relation between the two tables, and with this information, the data source can access the SQL backend and retrieve the master detail data correctly. As an example for parameterized queries, I open the detail level query definition in the Properties window. I bring up the dialog to edit the FilterString property. I add a criterion and select the field trips.length from the list. I choose the operator is greater than or equal to, and then I click twice on the small icon next to the entry field for the comparison value. After the second click, the field is ready to accept a parameter name, but I haven't defined a parameter yet. I click the field and a context menu appears. Now I can use the submenu Bind to create a new report parameter. Note that the menu also refers to a query parameter. For the example, I don't need to create this manually, but keep in mind that it exists. You need query parameters in advanced cases. For example, when you query from a stored procedure that requires arguments. The values in the report parameter dialog are familiar. I enter name and description, and I set allow null to true. Note that the type has been adjusted automatically to that of the field used in the criterion, so I don't need to change it. To complete the filter, I add a custom criterion in the editor panel. This checks whether the user has entered a value for the min length parameter before applying it. Now I close the dialog. Three things have happened now. Obviously, the report parameter has been created and the filter string on the query is configured. However, a look at the nested parameters collection of the detail query shows that a query parameter has also been created. It maps to the report parameter of the same name. The structure is similar to that used by the JSON data source, where report parameters mapped to path and query parameters within the URI. I bring up the query editor, and there is the query parameter with its @ prefix as part of the SQL code. Depending on your situation, you may not have to deal with this low-level code, but it's good to keep in mind where it is. I test the report now. When I submit the parameters without entering a value for the minimum length, all data rows appear, rendering a total of 52 pages. Now I enter a test value of 250 and submit again. The very first block is now much shorter, and the total length of the report is cut to 40 pages. The parameterized query seems to work, and like the web service sample, the filtering logic is executed on the server side and optimizes the amount of data transferred to the report. And that's it for this video. If you liked this video, please give us a thumbs up or leave questions or comments below. And don't forget to subscribe and ring the bell to get notified anytime DevExpress releases new content. Thanks for watching, and thank you for choosing DevExpress.